Susceptibility testing for Staphylococci other than Staph aureus, or SOSA, has become increasingly complicated as more laboratories use MALDI-TOF to routinely identify these bacteria to the species level. In particular, accurate detection of methicillin resistance has become more complex. The sensitivity and specificity for detecting methicillin resistance varies between different species of SOSA, depending on what method of susceptibility testing is used, as well as the breakpoints used to interpret the results. Some of the questions we'll discuss today include: what is the gold standard for detecting methicillin resistance in SOSA? Next, how will the recommended breakpoints for detection of methicillin-resistant SOSA change? And finally, why am I calling these SOSA instead of coagulase-negative Staphylococci? Welcome to Editors in Conversation. This episode is brought to you by the Journal of Clinical Microbiology, available at jcm.asm.org and on Twitter @jclinmicro. I'm your host, JCM Editor-in-Chief, Alex McAdam. This podcast is supported by the American Society for Microbiology, which publishes JCM. I'm joined today by two expert guests. Dr. Romney Humphries is the Medical Director of the Microbiology Laboratory and a Professor of Pathology, Microbiology, and Immunology at Vanderbilt University Medical Center. Dr. Humphries is a member of the Clinical and Laboratory Standards Institute, or CLSI, Subcommittee on Antimicrobial Susceptibility Testing, and a member of the Outreach Working Group and Breakpoints Working Group, which report to the subcommittee. Dr. Humphries is also the newly appointed editor of mini reviews for JCM. Romney, thanks for joining us.
Well, thanks so much. It's a pleasure to be here.
We're also joined by Dr. Lars Westblad. Dr. Westblad is the director of the Clinical Microbiology Laboratory and an associate professor of pathology and laboratory medicine at Weill Cornell Medicine. He's a member of the CLSI Coagulase-Negative Staphylococcus Ad Hoc Working Group, member of the CLSI Working Group on Outreach, and member of the CLSI Document Development Committee on M63, Principles and Procedures for the Gram stain. Dr. Westblad is also a member of the editorial board of JCM. Welcome, Lars, and thank you for being here.
Thanks so much. Pleasure to be here.
We'll mainly be talking about a JCM paper that came out recently titled Evaluation of Surrogate Tests for the Presence of MEK-Mediated Methicillin Resistance in Staphylococcus hemolyticus, Staphylococcus hominis, Staphylococcus capitis, and Staphylococcus warneri. Romney was the first author and Lars was the last author on the paper, which was prepared by them and other members of the Coagulase-Negative Ad Hoc Working Group of the CLSI. This paper provides data in support of a change to the breakpoint for oxacillin for SOSA, a change which the CLSI will introduce later this year when they issue the next edition of the M100. Romney, let's start with you, please. I thought it was interesting that you introduced this term SOSA for Staphylococci other than Staphylococcus aureus. In the past, we've always called these coagulase-negative Staphylococci. Convince me why we should make the change.
Yeah, well, I think it's a great question, and really it was a matter of convenience for us. As you mentioned, traditionally we sort of bucketed the Staphylococci into those that are coagulase positive, and for humans that means Staph aureus, and then anything that's not Staph aureus we kind of bucketed as coagulase-negative Staph. And of course, we know now that's not nearly as simple. And in fact, Staph that we started evaluating as we kind of marched our way down this project on evaluating how to test Staphylococci started with Staph pseudointermedius, which is neither a typical human pathogen, nor is it, in fact, coagulase negative. Interestingly, we then followed that up with studies on Staph schliefferi, which one of the subspecies coagulans, is also coagulase positive. And so at the CLSI level, and as authors of this paper, we started having all these sort of caveats to the coagulase-negative Staph. So coagulase-negative Staph and Staph pseudointermedius and Staph schliefferi, except for this Staphylococcus, which might be, anyways, it got very complicated. And so we came up with, rather than this really long mouthful with all these caveats, this sort of fun term of Staphylococcus other than Staph aureus. Plus, it's fun to say. SOSA kind of has a nice ring to it. So
it is fun to say. I have high hopes for it catching on.
Makes me want to do a dance.
Yes.
Yeah.
Kind of jazzy.
SOSA.
Yeah.
I agree. To me, this is part of the continuing ongoing death of coagulase-negative Staphylococci, which I think Lars suggested we do a cartoon about in JCM a while back, and we did do that cartoon. That was your idea, right, Lars?
I think so. Yeah.
You declined authorship. I've never understood. But Lars, can you give us an overview of the mechanisms of resistance to beta-lactam antibiotics in SOSA?
Yeah, the primary mechanism of beta-lactam resistance in SOSA is that mediated by MEK-A, which is a gene that encodes an alternative, an acquired penicillin binding protein called PBP2A. So this penicillin binding protein, PBP2A, is able to catalyze the cross-linking of the essential peptidoglycan cell wall in the presence of high concentrations of beta-lactams and essentially render SOSA immune to beta-lactams. The interesting thing is that there's also a homologue of MEK-A called MEK-C, which has also recently been described in SOSA associated with wildlife. In addition to the MEK-A and MEK-C mediated mechanisms of resistance to beta-lactams, some SOSA, especially Staph epidermidis and Staph hemolyticus, harbor penicillinases encoded by BLA-Z that render SOSA inactive, resistant to penicillin. But these organisms are still susceptible to the anti-staphylococcal penicillins such as oxacillin and methicillin.
Thank you, Lars. Romney, your paper focuses on accurately predicting for the presence of MEK-A, and we just heard about MEK-C from Lars. You used various phenotypic susceptibility tests as well as a test for penicillin binding protein 2A, which is the product of the MEK-A gene, as we've heard. Is detection of MEK-A the gold standard or the reference for detecting methicillin resistance in SOSA?
Yeah, it's really interesting. If you've ever been to the CLSI meetings, you'll hear we talk about the importance of the MIC a lot. In fact, at one point, I remember when I first started going, there was who we called the PK/PD mafia, who would go around saying that it's all about the MIC, with some subtext to that. But for Staphylococci, it's really interesting because it's not about the MIC. It's really about detecting MEK-A mediated resistance. And this is very unusual for susceptibility testing. I mean, most of our breakpoints are based on probability of target attainment, which is a concept that's really tightly linked to the MIC. And so the idea there is it doesn't really matter what the resistance mechanism is. If your MICs are elevated, then beyond what you could treat with, then that would be the definition of resistance. For staph, it's not that way. What we are most concerned about is detecting MEK-A, and now with the advent of MEK-C, or the discovery of MEK-C, I suppose I should say, we're more concerned about that. And in part, that's because in the early days of staphylococcal resistance to methicillin, detecting that presence of MEK-A was really, really difficult. The bacteria just didn't express it well. And this was true for both Staph aureus and also coagulase-negative staph. And so over the last 2 decades, really using that MEK-A as sort of the gold standard to define resistance to beta-lactams has become the norm. And like I said, that's really unusual. We don't do that for other organisms or other resistance mechanisms. It's a lot more about the MIC. In some ways, it makes it easier for us, right? We don't need those same outcome data, the same PK/PD modeling data, all these things that we typically look at. We're just looking for the presence or absence of a gene, and then the ability of all these different phenotypic tests to detect the presence or absence of that gene. In other ways, I think it opens up a lot of questions about the relative importance of some of these, like MEK-C, which we still don't really understand.
Thank you. I remember when I read the first paper I encountered where MEK-A was the standard against which a phenotypic test was measured. And I remember being kind of taken aback that it was a genotypic standard instead of a phenotypic standard. And you said this, but it was something I learned from your paper. Am I correct that it's the level of expression of the MEK-A gene, which of course determines the quantity of penicillin binding protein 2A, that determines where the cutoff will be for the various species? And do we know anything about what regulates those levels of expression?
It is, and I think, Lars can jump in here too, but what we found is we learned all sorts of things about Staph aureus in the early days of MRSA. Like, we knew that we needed to add more salt to our test media to help express MEK-A. We knew that we needed to have them at a lower temperature. So this is why clinical labs, our incubators are set at 35 instead of 37, is to help express that MEK-A. That's where that originally comes from in some ways. And so we knew all these little tricks to get MEK-A to turn on and be highly expressed in Staph aureus, using cefoxytins, another one. But as it turns out, you take that exact same MEK-A gene in that same chromosomal cassette and you put it in a different species, and all of those things that we understand about how it is expressed and the levels that it expresses it and what gets it to turn on no longer holds true. And so that's one of the challenges and kind of the fun part of doing this work is sort of learning how diverse these bugs are.
Thank you. Lars, the paper has a really nice summary of the CLSI updates to staphylococcal testing recommendations to predict the presence of MEK-A. And let's start in 1999. The CLSI established oxacillin breakpoints for SOSA that were different than those for Staph aureus. What were those breakpoints based on?
Yeah. So up until 1999, the breakpoints for detecting methicillin or MEK-A-mediated resistance in all staphylococci, the breakpoints were equal to or less than 2 for susceptible, or equal to or greater than 4 for resistant. But the authors and a few other investigators had essentially noted that there were discrepancies between oxacillin broth microdilution and MEK-A results for SOSA when they were interpreted using those breakpoints. So this provided the impetus for the study, and essentially the authors wanted to validate those existing breakpoints or to modify them to conform to the results of MEK-A testing. So going back to that point that MEK-A was really the reference method, or starting to become the reference method in this setting. So the 1999 paper essentially tested a collection of 50 SOSA isolates that represented 8 different species. And those 50 isolates were tested amongst 11 laboratories. They used a number of different phenotypic methods: diffusion, oxacillin diffusion, oxacillin broth microdilution, and also the oxacillin agar screen test. The important thing I got to lay out here is that that collection was heavily skewed for Staph epidermidis. So 58% of those isolates were Staph epidermidis. So, and the other 8 species were only kind of poorly represented, sometimes only 1 isolate per species.
Mm-hmm.
And so the authors ultimately proposed a new breakpoint, the breakpoint that we were all familiar with, that is an oxacillin MIC breakpoint of equal to or less than 0.25 micrograms per mil for susceptible, equal to or greater than 0.5 micrograms per mil for resistant. But the really important thing to stress here that, and they acknowledge this, that those breakpoints were really designed around Staph epi. And for the rest of the non-Staph epi SOSA, it was kind of up in the air what would be a good breakpoint.
Thank you, Lars. And Romney, since then, the CLSI has picked apart coagulase-negative or SOSA kind of one by one. Can you just give us a brief summary of the subsequent changes in the CLSI recommendations and how that leads up to your paper?
Yeah, for sure. So this is work that Lars and myself and Jennifer Diembard really started working on with CLSI, I think around 2012, maybe 2010 is when we first started discussions. And, at that time, really there were sort of 2 standards for testing what we called coagulase-negative staph. So it was oxacillin MIC with the 2% salt, and it was cefoxitin disc. The oxacillin disc had been kind of banished from the tables because it did such a poor job of detecting methicillin resistance in Staph aureus. And so there's a lot of concern that having that as an option for some staph, but not others, was confusing. So they should have got rid of it. And so, we, at the time that we first started looking into this, a couple of things were apparent. First off, labs now had technologies to identify these species down to the species level using MALDI-TOF predominantly. And so that really opened up the ability to start making species-specific recommendations for how you might test Staphylococci. In addition, in our institutions since 1999, it's been this increasing complexity of our patients that we see. So there's more and more immunocompromised patients. There's more and more device usage. So the coagulase-negative staph are becoming more and more important clinically. And so these things kind of all came together, and that's how we started the work. And, it was interesting. The first organism, as I mentioned earlier, that we started with was Staph pseudointermedius. And the reason we started with that one is that there was data from the veterinary CLSI guides. And I don't know if everybody in the audience knows this, but there's a whole separate CLSI document devoted to vets, which has all sorts of fun things like dolphin breakpoints and chicken breakpoints and salmon breakpoints. But they essentially had done a lot of work with Staph pseudointermedius because it's a common canine pathogen. And what they found was cefoxitin just didn't work for this organism. And so we wanted to look at that in the human isolates that we were now all of a sudden identifying with a lot more frequency in our labs. And so, like I said, we started our work there. We kind of wanted to challenge some of the standards. So we looked at oxacillin testing with and without the salt. We looked at cefoxitin testing. We tried out a couple of other beta-lactams as sort of surrogates. But at the end of the day, the things that seemed to work the best was that basic oxacillin test that had been used for so long. And also the oxacillin disc, which we had to reinstate to the tables to allow testing by disc diffusion for these, infrequently isolated but still important organisms. So that was the first kind of big update to the tables. We then looked at Staph schliefferi, which, as I mentioned, is very similar to Staph pseudointermedius, where oxacillin is really the better predictor of MEK. And then we went back to the Staph epidermidis. As Lars mentioned, the breakpoints that were in the table were really designed for Staph epidermidis. And so we were curious to see if the bugs had changed much since 1999, if we looked at contemporary isolates. And what we found essentially reaffirmed what the authors had found back in 1999. But then in addition, we also, for the sake of transparency, added oxacillin disc back in because that worked just fine for Staph epidermidis. And so these were sort of the stepwise changes that we took. The other big thing that we did at that time was eliminate cefoxitin disc as sort of the catch for isolates where you weren't really sure if they were MEK positive or negative. And so historically, we used to say if your oxacillin MIC falls in this gray zone of 0.5 to 2 micrograms per mil, and it's not Staph epidermidis, it might have MEK and it might not have MEK. And how you figure that out is you do a cefoxitin test. But we realized, well, there's only like 1 or 2 isolates of these other species that inform that recommendation. And we knew that for some species, cefoxitin did not work at all. So we eliminated that recommendation and told people to go ahead and do a MEK PCR or a PBP2A test.
Thank you. So we've got our background now. We've got the study in context. So let's start talking about the study in a little bit more detail. And Lars, let's start with you, please. What species of SOSA did you use in the study and how did you select those?
Yeah, so we analyzed 4 species, Staph capitis, Staph hemolyticus, Staph hominis, and Staph warneri. And they were essentially chosen based on their distribution in a range of human clinical specimens published in 8 studies from around the world. And I should state that those clinical specimens were predominantly bone and joint and also bloodstream. We excluded Staph epi because, as Romney has mentioned, we recently analyzed that. And so that was really the starting point. And, I think it's kind of interesting that of all those 8 studies that we reviewed, none of them were from the US. And I think it'd be kind of cool to understand, now that many labs have mass spectrometry in place, what the prevalence of SOSA are, at least from sterile sites in the United States. So that's something I'm really interested in kind of examining.
It would be good to know. I agree.
Well, and Lars and I were actually just talking about this the other day because we identify all of our Staphylococci, like every single one here at Vanderbilt. And when I was looking at our data, I'm relatively new to this institution. And one thing that's so fascinating is seeing the difference in organism epidemiology between 2 facilities. And what we see, of course, Staph epi is always the number 1, but we see our number 2 is Staphylococci, which was a little bit surprising to me. And then Staph saprophyticus is our number 3 Staphylococcus species that we isolate, which was really like kind of mind blowing because when I was at UCLA, we really did not see it very often, like maybe once or twice a year.
Does that reflect the source, the sample source?
These were blood isolates.
All blood, really?
Yeah.
That's surprising.
Crazy. Yeah.
Fascinating.
Romney, and I'm going to encourage people to look at the paper as well to understand this because it's going to be a lot, I think. But Romney, take us through the different methods of phenotypic testing that you used in the study.
Yeah, so we wanted to look at sort of the basics that we had identified as sort of being the best methods to predict the presence of MEK. And so from a phenotypic testing perspective, we looked at oxacillin, disc diffusion, and MIC. And that MIC, again, is done with a 2% salt added to the cation-adjusted Mueller-Hinton broth. We also looked at cefoxitin MICs and cefoxitin diffusion. And one of the things that we did was look at a variety of different disc manufacturers as well as media. And the reason we did that is really interesting. Even though our media is standardized, there is some brand to brand variability that we've noticed as we've been doing all of these studies. And so we wanted to make sure that whatever recommendation we made wasn't skewed by the fact that we had picked brand A over brand B, or one disc manufacturer or the other. And then in addition, we looked at, of course, our gold standards were MEC-A PCR, and we did do MEC-C PCR as well. They were all negative as expected, and PBP2A.
Thank you, Romney. Is this relatively new to be concerned about what brand of materials you're getting? I remember this first coming up in a UCAS study where they compared discs from a bunch of different manufacturers and found some significant differences. But before that, I guess I didn't hear much about it or think about it perhaps as much as I should have.
I mean, we're fortunate here in the United States that things are fairly regulated. I know when the European study came out from UCAS, they included manufacturers from all sorts of places where maybe the quality assurance is not adhered to quite as well. When we talk about the media, there is what they called historically the golden pound of Mueller-Hinton, which was sort of the gold. No, it sounds funny.
I can't wait to find out what this is.
And the golden pound comes up, I swear, like every CLSI meeting, somebody mentions this golden pound. But it was a pound or, a stock reference of Mueller-Hinton broth powder that was kept by the CDC. And every time a new lot was made, it was compared to this golden pound to make sure that the composition was the same and the performance was the same and all these things. Since then, we've, in an ISO document that sort of outlined what the standard is for this media composition, but you still see some variability. The different ions in the media, it's a complex media. And so getting it just right every time is challenging. And we didn't look at blood media, but just as an aside, one of the things that we found really critical when we looked at more fastidious bugs is if they're using sheep's blood, how old that sheep's blood is. Because if it came straight out of the sheep, then all those erythrocytes are nice and in good shape. And whereas if it's been sitting around for a week or two before they make the media, they're lysed a little bit and different organisms will grow better or worse based on that age of the sheep's blood. And that's not something that's, delineated in the ISO standards. So yeah, this lot to lot kind of question does come up a lot. And at CLSI, we're actually really interested in, as people develop new drugs or new tests, to make sure that they establish that there's no variability between different lots of media, different lots of discs for these tests. Because if you're only ever doing one, and that really is skewed in one direction or the other compared to any other media manufacturer, it can really influence, where your breakpoint winds up, how the test performs, all these things.
So just to go back to the sheep for a second, I learned so much from that. The golden pound, the sheep for a second. When you say it's the age of the sheep's blood, you mean it's how long the sheep's blood has been outside of the sheep, sitting in the laboratory before the media is prepared, as opposed to how old the sheep was when the blood was collected. Is that right?
Although that may also play a role. And and I don't know, Lars, you should talk about the different courses that they looked at.
Well, I was going to bring that up.
Yeah.
So there's a wonderful tale from CLSI where they were trying to develop a susceptibility method for a biologic, a lysine. And the presenter stood up and said, I've tested doing broth microdilution using sera from this horse. And then someone in the committee said, well, have you taken sera from different breeds of horses at different times of year? Yeah. And I thought that was the coffin, the nail in the coffin. But sure enough, the presenter came back next time and said, okay, the only horse I couldn't get sera from was Arabian mares, but I've got everything else and taken at different times of year. So I thought that was kind of a brilliant thing.
Cool. Yeah.
I love it. I'm so happy right now. That's awesome. Yeah. I've got to start going to these CLSI meetings. Let's turn back to your study. Gosh, I've just about lost my place here. There we go. All right. So Lars, this is the big question. Can you please take us through the results of the phenotypic testing using oxacillin and cefoxitin from your study?
Absolutely. Just to recap, as Romney had stated, we did sulfoxetine and oxacillin broth microdilution and distaffusion. And we analyzed the data using a number of different breakpoints. Breakpoints for SOSA, breakpoints for Staph aureus. I think in total, Romney, correct me if I'm wrong, we analyzed 8 different breakpoints. And so it was an extensive evaluation. Now, the crux of it is that no single breakpoint performed well across the 4 species of SOSA that were tested when we viewed the data independently. So that's when we looked at the data for each species individually. We noted unacceptable false resistance and false susceptibility for a number of the different species. I think Staph hemolyticus was atrocious, wasn't it, Romney?
Oh yeah, it was really bad. Yeah.
Nothing worked well for Staph hemolyticus. And so I think my major take-home points would be that, ultimately we had to design or propose a new breakpoint, which was essentially moving up a dilution, so susceptible being equal to or less than 0.5 micrograms per mil, and resistant being equal to or greater than 1 microgram per mil. And when we applied that breakpoint, we had acceptable false susceptibility and acceptable false resistance.
That's even with hemolyticus?
It was still not ideal, but I think you're going to touch upon that later in the session.
Yeah.
It wasn't ideal, but when we looked at all the data aggregated, it was
as good as we could get.
The best you could get.
The best achievable. All right.
Yeah.
So Romney, and Laura's touched on this, but Romney, just to put a pin in it, this will be the breakpoint that CLSI will recommend in the next version of the documents, which are coming out a little bit late this year, but are coming out soon, right?
Yes. Yeah, that's right. Yeah. And, the deliberations at CLSI were really, really interesting. We did this work and we kind of crunched the numbers. And I mean, like Laura said, we really tried everything existing, because one of the things you don't want to do when you're setting new standards is to deviate wildly year from year, right? I mean, the goal of our group was to keep the breakpoints the same as closely as we could. And one of the differences, I mean, the reason we wound up recommending that shift was to get rid of a lot of false resistance, which I think at the time that the first studies were done in the late 1990s, we didn't have the same information that we do now about the treatment outcomes for patients with vancomycin compared to a beta-lactam, right? And now we know, I mean, calling something falsely resistant is almost as bad as calling it falsely susceptible for these organisms. I mean, it's, of course, borrowing from the Staph aureus literature, but I still I believe that to be true. And so that was the reason we recommended this one dilution shift. But, the one thing that is important to think about at the CLSI, even though we don't use it as our primary determining factor, but it's the FDA. And the reason we have to consider that is if we propose a breakpoint that is not recognized currently by the FDA, we then have to put together a rationale document to submit to the FDA so they could decide if they're going to agree with our rationale or not. And the reason it's important to get FDA on board with our breakpoints is that is how commercial test systems are able to update to get the breakpoint on their panels and cleared by the FDA. So it seems kind of like this annoying, hurdle that we have to get over. But at the end of the day, if we want labs to be able to use what we find from these studies, we need to consider this. And, is it really worth moving that breakpoint one dilution and, requiring us to kind of jump through these hoops to try to get it recognized by the FDA? All the manufacturers that are performing routine testing, the commercial systems like the Vitech, like the Phoenix, like the Microscan, all would have to go back and redo clinical studies to show that their test systems would work with this new breakpoint and get it updated. So I think, while we agreed that it was the right thing to do, it was the best data in hand, it really did show an improvement. I did want to emphasize that, when labs get that version of M100 in March, don't expect your commercial manufacturers to have updated. And they may, in fact, not need to update because many of them achieved clearance by comparing their results back to that MEK-A PCR. And if that was okay with the breakpoint that they were applying on their automated system for the bugs they tested in their trials, then it probably still stands. So it gets really complicated, but that's essentially where we are right now.
So that was really valuable. I think it's difficult for people to understand and keep track of that relationship between CLSI recommendations and FDA recommendations. Do you know yet whether the FDA will accept the new breakpoint, or is that still a discussion that's in process?
Yeah, so we have not prioritized submitting the rationale document to the FDA yet, in part because of all the different things that we're trying to get agreement with the FDA on. This is a lower priority issue, in part because we do believe, because these systems were compared back to MEK-A PCR in many cases, they're probably okay. But also a big consideration is our work is not done yet. We have a lot of other staphylococcal species we want to look at. And so rather than doing this piecemeal with the FDA, we'd rather do it in one kind of fully formed argument.
How can all right, so when the new recommendations come out from CLSI, those of us who have automated systems, which for susceptibility testing, which is most laboratories, I think, we'll have to figure out whether or not those were calibrated for MEK-A. How can we know that? How do we find that out?
So I think asking your manufacturer is the best way to do it.
Yeah.
And we'll talk a little bit on what Lars and I think labs should do, I think.
Okay, we'll come to that. Lars, I thought it was really valuable that you analyzed how the new breakpoints introduced in your paper performed using data from previously published papers on additional species of SOSA. And what did you find when you looked at that?
Essentially, we found they worked splendidly. So if you just break out the species that Romney had discussed earlier, so Staph pseudointermedius, Staph schleiferi, Staph epi, when you looked at the new breakpoints, looked wonderful. You observed no false susceptibility and only one instance of false resistance. So just with those three species, everything was dandy. And when you combined all the 7 species together that had ultimately been analyzed throughout the years, we still came up with an acceptable false susceptibility and false resistance rate. So I think it's the best that we can really do with the methods that we're using.
It is nice to see some simplification coming out of this, I have to say, as a user, as a consumer of the guidelines. It is nice to see things moving in that direction. Romney, you also looked at an immunoassay for penicillin binding protein 2A, which is, as we mentioned, the protein encoded by the MEK-A gene. How did that assay perform in your study?
Yeah, so we looked at one assay, it's a lateral flow assay by Abbott, and it worked great. I mean, every time we've included this assay in our studies, and we've done it for Staph pseudointermedius, Staph schleiferi, Staph epi, these guys now, it looks fantastic compared to the PCR results. There is a second method that's available. It's a little bit more tedious to run. You have to do some induction steps. But the difference between the assays is the Abbott assay is not FDA cleared for anything other than Staph aureus, where the other more tedious assay is FDA cleared. So Lars has been doing some really good work, and I'll let him talk about this, kind of trying to convince the company to use some of our data to get clearance for SOSA with that test. Because I think that really it's the best thing that we can do. I mean, I feel much more comfortable trusting that PBP2A test over any oxacillin MIC or DISC or whatever result. And in fact, that's what we do in my lab. We validate it offline or off-label, I should say, for SOSA. And if we have an isolate that we need to test, that's the first thing we do.
Thank you. And Lars, we heard a little bit from Romney about this, but what would you recommend for clinical laboratories that are trying to decide what approach to take for testing susceptibility and detecting MEK-A using phenotypic methods? Where would you begin?
Yeah, absolutely. That's the $1 million question, isn't it? Well, what's the news that you can use? In my opinion, just as Romney stated, for SOSA, other than epi, pseudointermedius, schleiferi, for when you really do need susceptibility testing, not just willy-nilly, the method that you should be using is an immunoassay or MEK-A PCR to detect PBP2A or MEK-A respectively. And we've heard about the 2 immunoassays that are out there. One is a little bit more tractable than the other, but both will get you the answer.
Thank you, Lars. Romney, anything to add to that? You gave us your lab practice now and your recommendation. Anything to add?
Yeah, I mean, I think, I have a couple of thoughts. One is, only to be doing testing when it's really necessary. One of the things that my lab did up until very recently is we performed susceptibility testing on every single staff from blood. And really that's not value added, right? I mean, it's a lot of extra work. And in most cases, these are bloodstream contaminants from the phlebotomy. And so I think, really being thoughtful about when you perform testing. There's been study after study after study that shows most of the time these things are just skin flora contaminants. So that, that's the first step. But then if you really do need to do testing because it truly is causing an infection, then it's time to really do the best test you can. And I think, clinically, when you talk to infectious diseases physicians, so many of them, the knee jerk for coagulase-negative staph or, SOSA is to go straight to vancomycin because they just don't trust the oxacillin results. And part of that's sort of the lore over years and years of experience of these sort of kind of crappy tests that didn't always detect resistance when they should have. But I do believe if labs can implement better testing, if we can do this in a more robust manner and really detect both resistance and susceptibility, presence and absence of MEK-A, then maybe we can start shifting people towards more use of beta-lactams and not just knee-jerk going to vancomycin in every case. But it'll take time to have confidence in the testing that we provide out.
What's the difference in cost between doing a phenotypic assay, by disc diffusion or something accessible like that, to doing it by the immunoassay?
Yeah, that's a good question. Lars, do you have an answer to that?
Likely considerable.
Yeah. Well put.
I mean, disc diffusion is wonderfully inexpensive, and that's why it's so widely applied. Where a number of these kind of bespoke immunoassays are a little bit more out there, and not to mention PCR is kind of probably a level above.
Tenfold levels above, perhaps.
But then again, if you compare it to a daily dose of vancomycin or, beta-lactam, it really is, put it in context a little bit, I think. Is the important
thing. That's a very good point. And you also mentioned, Romney, looking to see which isolates you should actually be doing susceptibility testing on. So even though the per susceptibility cost may be higher, you may be able to avoid some of the increase by focusing your testing on the appropriate isolates.
Yeah, that's totally true. And I'll tell you, one of the biggest kind of points of contention through this whole work at CLSI has been, do we really want to be putting out more refined recommendations for testing these bugs when we don't want labs to be testing them, except for in these cases where they're really clinically relevant? And that, I think that comes up every time we present any of this data. Wouldn't you agree, Lars?
I do absolutely agree.
Yeah.
But you're very good at handling it, because I think one thing you said that kind of resonated with me, we know it's broken, so why shouldn't we be trying to address it and fix it?
Yeah.
And that's what the groups try to do.
What have we missed? What else should people know about this?
Well, the work's not done.
Mm-hmm. More species to look at, right?
Yeah, and I think Lars is getting geared up to launch the next organism. Do you want to kind of preview what that'll be for us?
The next really big organism is Staph saprophyticus. We know that nothing works well for Staph saprophyticus. Again, that's from ancient lore when you look back in the literature. Also from some of our veterinary colleagues, because a subspecies of saprophyticus is associated with bovines. And so that's our next big task. And then we're going to slowly whittle down. And as I said, I'd love to see a prevalence distribution in the United States, and that could potentially guide the next steps.
Thank you, Lars. Romney, anything to add?
No, I don't think so. They're fun bugs to work with. I honestly, if you'd asked me a decade ago, would I be working on, the coagulase-negative staph to this extent? No, but it's been really lots of fun.
I think of you as more of a gram-negative person.
Yeah, I am. Yeah.
But Lars, I think of you as a staphylococcal person.
I'll take that.
In a good way.
I'll take that.
Well, thank you both. This has really been a lot of fun and very educational. People who hung in hoping I was going to do a game at the end, I'm sorry. I had a heck of a morning and I wasn't able to put anything together. We will put the links to the article we discussed, as well as a few other things in the webpage for the podcast. You can find the Journal of Clinical Microbiology at jcm.asm.org. Thanks for listening.